Today we're going to look at rational functions, and we've learned about these specifically on lesson 1-5. We talked about parent functions. You learned this also as being called this reciprocal function. And that just means it is 1 over x, okay? It's just like reciprocal means you flip something from the numerator to denominator, so it's just a flipping of the linear function, but it looks totally different. We've learned it as a graph that looks like this, where it has these two curves with an asymptote in between. Now, there could be other transformations that have occurred, but for general purposes, that's what a reciprocal function will look like. The asymptotes are what divide it. This would have two asymptotes, a vertical and a horizontal asymptote. An oblique asymptote would occur if, say, the function looked like this. There it would be, where you have a vertical asymptote, but the oblique is not horizontal, it's then diagonal. Okay, so that's what that would look like there. And then finally, a holes, we've learned this is a removable discontinuity. This occurs anytime something has been canceled. And so there's the note for the oblique asymptote. All right, so let's look at some examples here. First, just make sure you're aware, vertical asymptote divides it this way. This is an infinite discontinuity. Okay, that's infinite discontinuity. Horizontal would go this way. That would have to do with the end behavior. It would help us find our end behavior because we could tell what is happening as x approaches the positive infinity to the right, or as x goes to the left to negative infinity. So that's what that'll help us with there for each of those. All right, so first, it says find the domain of this equation and the equations of the vertical and horizontal asymptotes, if any. Well, there are some rules to help us out. First, to find a vertical asymptote, you set the denominator equal to 0. So that V dot A stands for vertical asymptote. Set denominator equal to 0 and solve. Okay, so my denominator is x minus 1. So I would take that x minus 1, x minus 1 equal to 0, and I would solve it. And I would find that x equals 1. We have a vertical asymptote when x equals 1. That's an infinite discontinuity. To find a horizontal asymptote, you use the rules Bobo, Botten, and Eats DC. Now I'll explain those. Bobo stands for bigger on bottom, y equals 0. Botten stands for bigger on top, no horizontal asymptotes. And finally, Eats DC, our exponents are the same, divide coefficients. So this is talking about the exponents here. I have an exponent 1 and 1 up top. My exponents are the same. Since my exponents are the same, this rule says exponents are the same, divide coefficients. So I would take this 1 and this 1 here. And so my horizontal asymptote would equal 1 divided by 1. Whoops, not 1 divided by x, I'm sorry. 1 divided by 1, which is 1. So I should have a vertical asymptote at x equals 1, and I do. That's this one, x equals 1. And I have a horizontal asymptote at y equals 1. So my domain would be left over defined, which says how far to the left. This graph extends on forever to the left, but there's a break here at the vertical asymptote. So we have a break at 1. You're never equal to a vertical asymptote, so I do a parenthesis. We pick right back up on the other side of that vertical asymptote, and we go on forever. Or you could say that x cannot equal 1. You could do it this way. And if we wanted to find the range, it would be exactly the same. The only thing, I say exactly the same, the only thing we would change is if you were going to write it in set builder, you would say that y cannot be equal to 1. All right, so let's do another one, and we'll go a little bit quicker this time. So I'll talk out the rules. You see here, well, let me start first with vertical asymptotes. To find our vertical asymptotes, we would say that 2x squared plus 1 equals 0, and we would start to solve. So 2x squared would equal negative 1. That would make x squared equal to negative 1/2. And then you would take the square root. And we cannot take the square root of a negative number. So there are no vertical asymptotes. We'll see that here in a second when I'm going to show you the picture. Well, I guess in your set of notes you can already see it. As for the horizontal asymptotes, this follows the rule, not Bobo, I'm sorry, eats DC, because the exponents are the same. So you would put your y as, and I'll just circle it so you can see this time, 4 divided by 2, which equals 2. So we should have only one asymptote here, and we do. It's this one at y equals 2. So there's the equation for the horizontal. There's no vertical asymptote. And the domain, it looks like it's all reals. So we can write that as negative infinity to positive infinity, or x is an element of the reals. And then the range, it appears to me that the highest this travels is 1, 2, 3 units up. That's the highest, but we always go lowest to highest. So it goes from 2, and we do not touch that value, 2 to 3. It's in between there. Or you could say 2 is less than y, which is less than or equal to 3. Now, this one is a little bit trickier because they don't have it as one fraction. They have it broken up. So here's what we're going to do. We're going to add this by getting a common denominator. So I'm going to have to put this over 2x squared plus 1, which means the top, you're going to have to multiply by 2x squared plus 1. And then we can add these together. Now up here, that would equal 8x to the 4th. And I distribute that through, and then I multiply that, plus 4x squared, and then I will have this plus 3 over here. All that will be over 2x squared plus 1. And because the denominator is the same as last problem, we can state outright that there's no vertical asymptote. As for horizontal, this would be bigger on top. So there's also no horizontal asymptote. Since we're bigger on the top, since the 4 is bigger than the 2, I can't even see the 4 anymore. Since I have a 4, which is bigger than the 2, it would follow the rule, bottom, bigger on top, no horizontal asymptote. And the no vertical asymptote is because we cannot take the square root of a negative number. That's the same one as before. And then finally, if we wanted to find domain, we'd have to look at the picture here. Now, I never want to mess up on the algebra, so I always type in the original equation before we did that work, just to make sure in case we made a mistake. Let me try this again. Here we go. 3 over 2x squared plus 1. Hit the graph. I want to zoom out just a couple times to make sure. There we go. And I'll take a picture of this and move it on over to the other graph so you can see it here. And you can tell that we did do it correctly. Or there's no horizontal asymptotes, no vertical asymptotes. The domain looks like it's all reals. And the range, it looks like the lowest value is somewhere in between 2 and 3. Let's go back over here and see if we can count. I'm going to go find out what that value is real quick. I've gone to menu. I'm going to go to analyze graph. I'm going to look for the lowest point. Looks like it's 2.9. So the range would be, I have a lowest value of 2.9 to infinity. Now you go ahead and try this one.